I think this is the third Go conference I've been this year. And I think I'm the first person not related to the language or Google to open a conference. And I don't know if I should be flattered or terrified. I'm going to go with the second one. Some of you might have read this book called Crossing the Chasm. It talks about technology, it talks about products, and it does an emphasis on why products succeed and why others fail. And I'm not here to send a message saying that the Go programming language is going to fail, because the fact that there are, I think, at least 10 conferences this year around the world gathering thousands of people speaks by itself. So I'm here to send a message about maybe some things that we could improve as a community, and maybe things that we could look for the future for new programmers to come to the Go programming language. But before talking about that, I'd like you to meet someone. She's one of my heroes. Her name is Kathleen Booth. She was a research here at the University of London. This picture was taken, I believe, in 1950. That huge machine is called the ARC computer. And I think it ran with like more than 600 relays and 100 vacuum tubes. And this one was one of the first computers to be programmable. Kathleen and her future husband published this paper in 1947 called Principles and Progress in Construction of High-Speed Digital Computers. And one of the sections in the paper talk about the code. So it turned out that Kathleen figured out a way to program this computer beyond just sending numbers. And that code became what is known as the first assembly language in history. I believe this is not very well known because the first assembly language in history was only used to program this computer, this huge computer that actually was very specialized to run very complex equations. And if you go to the Wikipedia page about the assembly language, there is no mention about her at all. You have to actually go to her page to learn about her. So that made me wonder why this person that was so influential in the 50s and 40s is barely known. And I really believe that it's because this huge machine was completely unique. And she was actually the creator of the language and also the user of the language. And there were a few other researchers with her, but maybe the number of people that knew how to actually program in that assembly language was probably less than 10 people. So that brings me to this graph of Gophers. And what the book Crossing the Chasm describes is the life cycle adoption of technology. Right? The first Gopher is the innovator, is the people that arrive first to new technologies, people that are actually interested in how the technology works. They're interested in how the internals work. They're interested in helping to improve the internals. The second Gopher is the early adopter. They are actually really interested in being the first people in adopting technologies. They want to influence other people. They are those people that write all the test frameworks for new languages. Those people that write the draft consensus protocols for new languages. How many of you have written a draft consensus protocol in a new language? Yes, anyway. Those are the early adopters, right? And then we have the early majority, people that actually are interested in using the language. They want to have the tools necessary to be productive in the language. And I believe that those are probably most of you here. And what the book describes are those little gaps in the middle of the graph that it calls the chasms, right? So there are like specific points of time where there is a switch between those group of people, and that's what we're trying to describe today. The first chasm between innovators and early adopters is actually pretty minimal. Most of the early adopters become innovators, and then most of innovators becomes early adopters pretty quickly, right? And then we have the second chasm where it's actually more dangerous because there is a possibility that if the language or the technology is not ready for the early majority, there is the chance that that technology is never going to be adopted, right? I believe this is not going to be the case of the Go programming language because we're already seeing people using the language in production. It grew beyond Google. It's not something developed specifically for Google anymore. So I'm going to talk a little bit about that today. So the first point is about early adopters. There is something that describes how early adopters arrive to new technologies. And it's based in this quote by Paul Graham that says, the best way to get those initial 20 users is to give people an application they want, which happens to be writing in the native language. And it happens that I mostly arrived to the Go programming language via Docker. I already knew the language before knowing Docker, but when I discovered Docker, I started to dig in the code, and then I discovered the Go programming language. And I think that's a very nice way to discover new technologies, right? And that's how early adopters arrive to actually new technologies via like new applications. And I'm not talking only about Docker. There are other like very well known projects like Packer or etcd, CoreOS, people that are investing in the Go programming language really heavily and were early adopters of the language become actually the people that develop these applications that actually bring more people to the community. So once we have the early adopters in the community, we just need to make sure that those early adopters help the innovators to bring the early majority to the language. And there are several challenges that I'm going to describe. And I'm going to try to give some ideas, personal ideas, about how we can improve the language, the community, our tools to help this early majority to come to the language. One of the first things that come to my mind is that the Go programming language was designed inside Google. That actually set the stage for a really nice language because it was designed by consensus. So every feature that was implemented originally in the language was designed by consensus. And people agreed that it was something useful for users, right? That brought us things like being able to upgrade from Go 1.4 to Go 1.5 and not having any compilation errors. For sure, there are minor issues, but there are some nice things that that consensus brought us that other languages don't have. But that made me think that, well, the Go programming language was designed inside Google, and it was designed for Google scale. But the community has grown beyond Google. And at some point, maybe Google is probably not the first use case for the Go programming language. So how could we make the community to participate in the decisions to improve the language, to evolve the language for the future community? Because as Christopher Alexander says, only the people can guide the process of organic growth in a community. If we don't help to the creators of the language, to the people involved in those tools with feedback, with pull requests, issues, we're not going to be able to make that growth organic. And this is very important because the moments that you don't actually participate in those decisions are the moments that you're just going to be in the dark when you upgrade to new tools and when you don't know what to do with the language. And there is this, there is something missing in this slide. There is a repo called Proposal where people can participate in providing feedback for the language. People can actually propose new changes to the language. It's true that the language is already frozen, but it's only the grammar that's frozen. A programming language is more than just a grammar for the language. We can propose changes for the compiler. We can actually improve the garbage collector, as we saw in the 1.5 version. And those proposals can create a stage for the future. So other new features that can land in the language easily if we can evolve the language in incremental steps. I'd like to talk about something completely different now. And I think it's a slightly skirt topic. I was at the Go conference in Denver a month ago, and my two favorite talks were about simplicity and how the Go programming language embraces simplicity. I remember one of the talks was about how someone actually chose Go because it was really simple for her to start with the language and be proactive in comparison to other languages and other frameworks. And I was wondering, is really simplicity what we actually are looking for? When I heard the stories about how the language was created and how Google decided that C or C++ weren't enough anymore to develop their applications, I wonder, did they really start new languages because they were looking for simplicity or because they were looking for something better. And I think we should try to change the message about the simplicity in the Go programming language and talk more about the goodness of the language or the goodness of the tools that we have. I think it's gonna provide much more clear information to newcomers about what the language strives for and what we're trying to accomplish. And I'd like to show you a few examples of what I'm saying about simplicity versus goodness. The first example is the HTML package. It's actually one of my favorite packages, and I barely use it at all. And I think it's one of the most misunderstood packages in the standard library. One of the things that I find interesting is that people come to the Go programming language because they think that it's very useful to create APIs. We have like very good primitives to create APIs. The HTTP handlers are fantastic to just sketch some APIs. And then as soon as someone needs an interface, they just put a layer of JavaScript on top. And they just call it a day. And actually, I still like to render HTML in the server side. And the HTML package is really good for rendering HTML in the server side. And it has several patterns, really well designed to do that. But I don't find people actually talking about the HTML package. And it's really simple. And from my point of view, it's really good. But we think that the simplicity of the standard library means that we don't need to use the HTML package. We just need to put JavaScript on top of APIs. And I really wonder why. I think we should actually talk more about these small gems in the standard library and less about adding more layers of complexity to the applications. The next point is, of course, dependency management. For a really long time, we have been talking about vendoring dependencies. Just write your own scripts, use GoGet, download all your dependencies and vendor in a vendor directory. We have wrappers around GoGet. We have reimplementations about GoGet. And I think it's time for us to stop trying to go like around GoGet and try new tools that actually provide this goodness instead of just the simplicity of GoGet. For almost 3 years, we have had the tools to vendor dependencies, and they have been proven that are not the best tools for doing that. So why don't we try to start over? Why don't we try new tools that are actually focused and provide this goodness instead of just trying to be simple tools? And the last example is obviously the forever debate about editors versus IDEs versus tools. If you look underneath the Beam plugins, or if you look underneath the several IDEs plugins, all of them actually end up calling the tools that the language provides. So why don't you just use the tools that actually are better for your workflow? It doesn't matter if you use an IDE or you just try to use a text editor. What it matters is that it works for you. Obviously, people are not going to open an IDE without knowing the language and being productive, because you need to know the language, and you need to know the tools that the IDE provides. And And at the end of the day, what you just want to do is get your work done, right? So use the tools that are better for you. Don't try to use tools only because are simple. And the last topic I want to share with you, it's about community. And it's about patterns. Probably most of you come from other communities and your experience in programming. But I'd like to talk for a few minutes about what I call patterns. And Christopher Alexander describes patterns in a really weird way. So he's trying to explain how patterns work in design and architecture. And it says, a general planning principle which states a clear problem that might occur repeatedly in the environment. He's trying to design a university with the help of people, and he's actually identifying all these patterns in a university. And what he's trying to do is trying to solve the problems that the university faces by solving the patterns that he observes in the architecture. And he says, we might regard the pattern as an empirical grounded imperative, which states the preconditions for a healthy individual and social life in community. And I think what he's trying to say is that we need to design a community to be healthy. And we need to get patterns that are going to make our community healthy. And we need to try to avoid the patterns that we might have seen in other communities. And we can just leave those out. And I really like how Andrew finished his keynote at the GopherCon in Denver, saying that Go can be the most inclusive community in the tech industry. The problem with us is that we're not going to be able to do that if we just keep repeating patterns that we have seen in the past. At some point, we just need to stop repeating ourselves again. Otherwise, we're just going to continue being the same communities with different languages. And I really like this quote that says, the early adopters set the tone of the community in ways that are often difficult to change. So we are here to actually set the tone for the community. We're just not here to learn. Each one of us behavior actually is reflected in the community. And the ways that we behave with each other are going to be reflected at the end at the community. And we're not going to be able to actually be the most inclusive community in technology if we just keep repeating the patterns that we have seen in the past. So before leaving the stage, I'm going to leave you with 3 of my favorite patterns that I think we should adopt. Be patient, be helpful, be kind. Thank you for your time. I hope you enjoy the rest of the conference.